Hi everyone. Today we're going to study the definite integral. Let us define the definite integral. If f of x is a function defined on an interval, this is a closed interval from a to b. The definite integral of f from a to b is denoted as the integral from a to b of f of x dx. And it gives the area bounded by the curve y equals f of x, the lines x equals a, x equals b, and the x-axis. There is a note here. Although the notation for indefinite integrals may look similar to the notation for a definite integral, they are not the same. A definite integral is a number that denotes an area, while an indefinite integral is a family of functions. For illustration, we have this figure. The area A, it's here, the shaded region, is bounded by the curve y equals f of x. This is the curve. The lines x equals a and the x equals b and the x-axis. Again, the notation of definite integral is this: the integral from a to b of f of x dx. In here, we see two small numbers in the integral sign. We call this the limits of integration, the a and the b. Specifically, the a is what we call the lower limit, while the b is the upper limit. Now let us study properties of definite integral. This is the first property. The integral from a to b of f of x dx is equal to the integral from a to b of f of t dt. We may write also that this is equal to the integral from a to b of f of u du. Property number 2, the integral from a to a of f of x dx equals 0. We can see here that the limits of integration are the same. Property number 3, the integral from a to b of f of x dx is equal to the negative of the integral from b to a of f of x dx. Property number 4, the integral from a to b of f of x dx equals the integral from a to c f of x dx plus the integral from c to b f of x dx. Here, c is any number between a and b. Let's see now the fundamental theorem of calculus. We have this fundamental theorem of calculus part 1, and it goes like this. If f of x is continuous over an interval or closed interval from a to b, and the function capital F of x is defined by capital F of x equals the integral from a to x of f of x dx, then capital F prime of x equals small f of x over the closed interval from a to b. This theorem establishes relationship between integration and differentiation, and it guarantees that any integrable function has an antiderivative. Specifically, it guarantees that any continuous function has an antiderivative. This is now Fundamental Theorem of Calculus, Part 2. This is also known as the Evaluation Theorem, and it goes like this. If f of x is continuous over an interval, or we say closed interval from a to b, and the function capital F of x is any antiderivative of f of x, then the integral from a to b of f of x dx equals the capital F of x from a to b. This is the notation that is commonly used in some of the calculus books, and we can still evaluate this into capital F of b minus capital F of a. This theorem states that if we can find an antiderivative for the integrand, then we can evaluate the definite integral by evaluating the antiderivative at the endpoints of the interval and subtracting. We shall evaluate some definite integrals on the next video. I hope you learned something from this video. See you again next time.